Hi guys, and welcome to week number 6. You are a third of the way done with the semester. This week you're going to be taking a look at different kinds of minerals and how they work tectonically and see if you can identify them for your lab. So let's take a look at where you're going to go. You're going to go into the weekly lab modules. Again, this is week number 6. In this week's virtual lab, you will examine physical properties of various minerals. You will identify mystery minerals by performing scientific tests virtually. When I click on the week 6 menu, there are 2 videos that if you are not in a face-to-face class or in my online class, I strongly suggest that you watch. You're going to be completely lost during this interactive. So watching the video will help you identify basic physical properties of minerals. And then there is a property that's a little bit difficult for some reason for students to figure out. It's determining planes of cleavage. So this young lady on this video does a really nice job of explaining how to figure out planes of cleavage. So watch that video, it's very short, and then you're ready to start looking in your virtual toolbox of rocks. So I'm going to go to the next page. On the next page I put the link. I also included a mineral identification worksheet that you can kind of work through. I strongly suggest that you print this out and kind of write on each of these so that when you actually answer the questions on your actual virtual lab, it's easy for you because I did pick 5 of the minerals straight from this within the actual assessment. So if you have them here, all you have to do is kind of pluck the answers off and put them on your assessment questions. So what you're going to do is you're going to go into the actual virtual lab. The actual virtual lab link is down on the bottom, so I'm going to click on it. It'll open you up in a new menu. So it goes into a little bit of detail of what exactly a mineral is and some of the physical properties that you're going to be using. Physical properties can be seen usually by a couple different methods. So there's different methods and testing things that it talks about here. Color is probably the easiest to identify, but it's the least reliable because minerals typically have different imperfections in them, but you'll start with that idea. Again, cleavage, this is the video that I asked you to watch. It'll talk about breakage, so you can kind of see different things of how they break and count the number of planes that it breaks on. So for example, if this little box was a mineral, I could figure out how many planes of cleavage it has, how many nice flat lines that it breaks on. And I can figure that out by using my fingers and touching. So for example, this one is parallel to this one, so that would be 1 plane of cleavage. This one is parallel to this one, so that would be 2 planes of cleavage. And then I have another plane opposite here and here, so that would be a total of 3 planes of cleavage. You're going to have to kind of know how many planes of cleavage different things have. And again, the video nicely illustrates non-conformity different shapes that aren't perfectly square, how to figure those out. Alright, so you're simply going to read through here the different physical properties that you'll be using, kind of testing out. The one that you'll be using quite a bit is a hardness test. It's the idea that if you were to try to scratch a mineral, how easy is it to scratch? Obviously a diamond is the hardest mineral, so it's going to be very, very difficult to scratch, whereas talc, think baby powder, is very, very easy to scratch, so it would have a low hardness number. So read through each of these physical properties so you're aware of each of them. Then you're going to kind of scroll down, and then it gives you actual different properties that go hand in hand with some very common minerals that you'll be looking at. So here are the different minerals you're asked to identify, and again on the assessment I chose 5 of them. So let's take a look at sample number 1. So if I click on sample number 1, it shows me a beautiful mineral that looks like this. Then you're going to scroll down here and it says physical properties. You need to kind of semi-test for them. The first one again is easy because it's based on pure sight. This particular mineral is white, so I would simply come down and where it says color, I would simply click in the white margin. Then it says streak. Well, obviously I don't have this mineral. A streak is simply a color that's left behind. If I physically take the actual mineral and I try to rub it against something, what color is left behind? Well, I don't know because I don't have an actual hand sample of this, so I'm simply going to come over here and click streak test, and it tells me it gives a white color. So I'm simply going to identify it over here as streak being white. So again, I'm going to come right here. Cleavage, again, I have to try to figure out how many planes of cleavage it has. Luckily for me, it kind of helps me out a little bit on a cleavage and fracture test. It says it has 1 plane of cleavage and it's irregular fracture. Irregular fracture simply means that it doesn't have a flat line, it has more kind of a bumpy surface. That's what fracture is. So one plane of cleavage, irregular fracture. So I'm going to start there. So cleavage is 1, and it told me the fracture was irregular. Pretty easy. So now I'm going to take a look at, okay, what is the actual crystal form? I'm going to come up here, and this one you have to kind of look at and take a decision of what form do you think, what shape do you think this best is. There is another image if you're not sure that you can click on, and it'll show you kind of another piece, another form of it to see if you can decide what shape it is. When I go back and through, you decide what you think it is. I'm going to say maybe prism. I'm going to kind of guess here momentarily, so I'm going to say maybe a prism shape. Hardness test, again, this is the one where you pretend like you're scratching it. How hard is it? So this one's kind of a hunt and peck here. I'm going to start off, I'm going to say, let's start with about a 3. It says it was scratched at a 3. So this is a very soft sample. So I'm going to say, okay, so could a 2 scratch it, an even softer mineral? And it says it was not scratched. So 2 could not scratch it, but 3 could. So we're going to give it a hardness of about 2. Luster, is it metallic or non-metallic? Well, this is very white in nature, very kind of dull, so I'm going to argue it's non-metallic. And then other tests that if I had the sample, if I could perform, does it bubble and fizz like Sprite if I drop some acid on it? Well, let's see. It does not, so no. Is it magnetic? Magnet test. It is not magnetic. If you could taste it, is it salty? Well, taste test. It is not. And the reason why they ask that is because calcite usually reacts under hydrochloric acid. Magnetite will tell you it's a magnetic property or pyrite. Salty taste would be referencing halite, which is typically what you sprinkle on your food. So this one does not have any other property that identifies it. So then I have to ask, okay, so what mineral do I think this is based on this example? Well, based on all these different present ones, I'm going to come over and you can either go back to your introduction, or I would suggest printing out that first page. I'm going to pretend like I looked at it and I said, hey, I think it's calcite based on it. So I'm going to grade that identification. And it said I missed the crystal form and the mineral name. So I need to go back up. Crystal form, so it's saying it's not a prism. So then this is kind of a playing with it. You have to kind of look. If I take a look, okay, maybe now is it maybe hexagonal? And again, hopefully you printed out that first page to help yourself out here. I'm going to say, okay, now I think based on new things, I think it's gypsum. So then I put grade identification. Again, I missed crystal form. So at this point, if you can't kind of decide the shape, kind of go through here and just kind of pick different ones until it says grade identification. Keep going until you get it, and then you go to the next sample recording on your sheet. The hardest part for most students is the actual crystal form. If you don't see a crystal form, obviously you're going to put not present, and it says yes, I got it right. So it was in fact gypsum. So if I return to the introduction, again, this is the page I suggest you print. There's the different forms, and then here was the actual one, and it says that gypsum has a hardness of 2, and I can scratch it with my fingernail. You're going to continue on trying to identify the different minerals. After you've identified all of them virtually, then you're going to go back into the actual content area. You're going to come up to the top and go to the next actual page, and then you're going to take the assessment. So for example, I'll show you just the first question here. It says, which of the following minerals has 3 planes of cleavage that are not at right angles? If you printed out that front sheet, the answer should be easy. So I would simply answer it, and then I'll go to the next question. I'm just going to randomly pick one here so I can show you the next one. Which one is represented by splintery fracture? Again, that front page told me that, and you should have found that as you were kind of going through the different minerals. I'm not choosing correct answers here. I'm just getting you through a couple different ones. Scratched by a mineral, not correct. Again, so there's some basic questions you're going to go through here, and then towards the end, it will ask you about 5 of those specific minerals that you just virtually tested. At the end, you'll submit. There is one question embedded within the assessment that deals specifically with El Paso, so that you have a little bit more of a connection in terms of what we're learning. If you have any questions, please reach out to me and let me know. Otherwise, good luck.